Alrighty, so first thing we're going to do is review long division using polynomials like we did yesterday. Okay, so there's our problem. Remember, we look at, get the highlighter. Look at that leading term. Anything, what do you multiply x by to make x squared? That'd be an x. So that's how many times x goes into x squared. X times, and then just like in regular long division, it's just an algorithm. We just follow the rules. Subtract it, -10 plus 2 is -8x. Bring down the next one, we start all over again. And we're looking at this. What do you multiply x by to get -8x? That's -8. But we subtract it. 2 minus 16 is -14. So this is an x minus 8 minus a 14 out of an x minus 2. Okay, but is there possibly a shortcut? There is. It's called synthetic division. So let's see. We'll get to that part. If we just kind of look at the numbers, by us lining everything up, like we held a spot everywhere. I guess that's really kind of all the numbers I need to look at. So we put the x minus 2 there. And you had a 1 and a 1 and -10, -2. Like the x squareds and the x's, they sort of disappear in importance when you have everything lined up perfectly. Like everything in this column had to do with x squareds. And everything in this column, oops, I wanted to change colors. Go back. Everything in this, oh, that looks awful. I didn't undo. Okay, everything in this column has to do with x's. And then everything in this column has to do with just constants. So really, I only had to pay attention to the number part, okay? And up here where the answer was, do you notice how what I was dividing into started out as x squared, but it dropped a power to x in my answer? And here they were x's, but it dropped a power to -8. Like we call that a depressed polynomial. Not because it's sad, but because it drops a power. Okay? And every single time we went through there, we had to take and subtract this row. Well, what if we had just turned that to the opposite sign to start with? Because remember, every single time these went away. We knew that's going to happen. That's the whole point of us picking the numbers we picked, so to make that part disappear. Okay? So this kind of leads us to our shortcut. If this is the problem we're working, first, I want you to think about what you're dividing by. What makes that 0? 2 does. So this is called the synthetic division. We're going to put a 2 in a box. So it's like whatever the divisor is, what makes that 0? Okay, that goes in the box. And then the only thing I need to worry about are the coefficients of what I'm dividing into. I'm just going to write those down. It's a 1, a -10, and a 2. Okay. And then I'm just showing you what to do. You need to write out steps. They're your notes. So you do what you need to do with them. But the first thing I'm going to do is I'm going to drop the 1. Because if there was a 1 right here, there was a 1 right there. All right, then I'm going to go to multiplying. I'm going to say 1 times 2 is 2, and then I'm going to add these up. Okay, see it from up above? -8 times 2 is -16. I'm going to add those up, and I'm going to put a box around that. The row down here at the bottom, oops, didn't mean to mark through. That tells me the answer. So if I started out with an x squared, that's the coefficients on the depressed polynomial. I start out as x squared. I'm going to get 1x minus 8. The part in the box, I put in the box because it's a remainder of the remainder of negative 14. So I'm going to add in a negative 14 out of what I divided by in the first place. But again, you're almost always going to see that way. But we change the sign of that number because that way we don't have to subtract. Instead of sitting there and going and subtracting every row, now we can just add every row if we change the one sign. Okay. All right, so let's try this again. I'm dividing by x plus 2. What makes that 0? Negative 2 does. Coefficients, what I'm dividing into across the top. 1x cubed, 4x squared, 6x's, and 4. Drop the first one. Go to multiplying and adding. Oh, remainder 0. That means that divided evenly. And if we started out x cubes, this is my depressed polynomial. It's the coefficients of my depressed polynomial. 1x squared plus 2x plus 2. Okay. All right, this one, divided by x minus 4, so I'm going to put a 4 in the box. That's what makes x minus 4 0. 2 on the x to the fourths, negative 11 on the x cubes, 11 on the x squareds, 4 on the x's, 4 on the constant. Drop it, multiply, add. Multiply, add. Multiply, add. Multiply, add. Remainder. Start out x to the fourth, you drop it a power, answer is 2x cubed minus 3x squared minus x plus 0 plus 4 out of that x minus 4. Okay. Dividing by x plus 3, put a negative 3 in the box. 2 on the x cubes, 0 on the x squareds, 0 on the x's, negative 54. Drop the first one, negative 6. Add them up. Add them up. It's negative 48. Add those up. 12, carry the 1, was that negative 102? That's my remainder. Start out x cubed, depressed polynomial. Got us an answer. Okay, now here's the thing. Will synthetic division always work? No. It only works when you have a polynomial and you divide by just x minus some number. Because notice how we just dropped this one. Like if we'd been dividing by, say, a 2x plus 3 into a 5x squared minus 9x plus 4. Well, 5 would be done. So let's say 50x squared plus 4. What do you multiply 2x by to make it 50x squared? That'd be a 25x. Like we'd write the 50 down. You would just drop the 50. And then also if it's any power is bigger than just plain old x, this is going to do us no good either. So the only time it works is when you're dividing by a binomial with a lead coefficient of 1. And if it's x minus k, you put a k in the box. So if it said, x, you're dividing by x minus 3, you put a 3 in the box. If you divide by x plus 7, you put a negative 7 in the box. Okay? All right, and then the other part of this lesson is something called the remainder theorem. So we just figured out, well, actually, yesterday we figured out this, that if you take some polynomial function, you divide it by a divisor that's also a polynomial function. It gives you a quotient polynomial, and then there's a remainder out of which you're dividing by. Okay, that's what we did with long division. But today, we went through and only divided by a binomial with a lead coefficient of 1. So instead of putting the divisor, let's put x minus k. And then, like we were talking yesterday, how you check your answers, 10 divided by 2 is 5, because 2 times 5 is 10. So if this is what's happening, this is what I started with, then what I'm dividing by, if I multiply that by the answer, that should get me back to the function. So that's all this is showing. Like they're multiplying that, and then multiplying this, which makes the x minus k's cancel out, and you get the plus the remainder. Okay. Now the thing about that, well, I just kind of put this in the book, out of the book, because it looked a lot nicer, and I was running out of time. So the remainder is either 0 or the degree of r of x is less than the degree of x minus k. So here's what this is saying. If we took some function and divided by x minus 9, then it either goes into it evenly, like whatever, let's say that's a degree 5. Then you'd have something x to the 4th, blah, 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 blah. Then the remainder out of x minus 9. But the remainder part would just be a number. Okay? Because what you're dividing by is x minus 9. Like you're going to get down to, like your remainder is not going to have an x in it because you're dividing by someone with an x in it. So it's just going to be some number, or it's going to be 0. Well, 0 is some number, so that's kind of a silly thing to say. But up here, if we were dividing by an x minus k, what makes x minus k 0? K does. So what if I took this, which was just what we started with, rearranged, and actually plugged in the value that makes what you were dividing by 0? Well, then where it says x minus k right there, I'd have k minus k, which would be a 0. Oops. But I'd still have that remainder. So this is kind of a big deal. It's called the remainder theorem. If you just want to evaluate a function, then you can just plug in what makes what you're dividing by 0. And then the remainder is, well, let me rephrase that. Sorry. It's going to be hard to rephrase it. Let me do one and I'll show you. There's 2 ways of evaluating this function. If I want to know what f of 2 is, I can do this, which will work all day. That's negative 3 times 8. So negative 24 plus 16 minus 34 minus 61. Negative 8. Down there we got what? Negative 95 to work with. So negative 103, which is not bad. You've been doing this for years. But look what else I can do. And I never had to deal with exponents. Because if you're just plugging in a 2, it's kind of working off the idea of you had some polynomial getting divided by an x minus 2. When we rearrange this, and I'm putting, like if it's x minus 2, I'm putting a 2 in there. F of 2 would just give me the remainder when I plugged in that 2. So it's kind of a cool way to evaluate a function, I think. If you want to evaluate it at -1, then just plug a -1 in when you do synthetic division. Squareds. It's 4. Okay, check it the old way. Plug a -1 into here. Oops. So there's -1 plus 1 plus 4. Oh, I got 4 that way too. And see, this one, I think that's probably just as easy. But when there's a bunch of terms and there's a bunch of things you got to take to powers other than like a -1, then a lot of times synthetic division is easier. So this is find the value of y. So we've got some polynomial function. It's just they're not calling it f of x or g of x. They're calling it y. and evaluate that if x is -5. So I'm hunting for what's the y value, and I plug in a -5. But again, just do synthetic division. That's what, 75, 106, -530. And you got it. One more, plug a 3, 1, no x squared. One carry the 2. H of 3, 78. Is that the last one? It is.